Hi, welcome to Book. Today we are going to discuss about solid principles. Solid is a set of five object-oriented design principles that help developers to write a clean, maintainable, and scalable code. With these solid principles, we can definitely write a proper way of coding. Even though when I'm appearing to Amazon interview, this helps me a lot. So definitely, solid principles is must and should required for every developer to do development. This is the core for any programming language. So please go through till end of this course. You will definitely get a very good idea on the solid principles. So let's start with one by one. So the first one is single responsibility principle. So what is single responsibility principle? A class should have only one reason to change. Each class should focus on a single responsibility. So if you are not understanding by this one, let's go with example. Let's see here. I have a restaurant class and it has five operations from order food to feedback. So restaurant class will be having all these operations. It has all these responsibilities, I can say. So now, a single class having multiple responsibilities. What will happen if I have multiple responsibilities? Suppose if we want to add few more operations, the class will grow like nothing. And if you want to change any of this service, like any of the operation, suppose prepare food you want to change. So complete object we need to test thoroughly and it may break somewhere, we don't know. And one more problem is it is tightly coupled. If you want to add more operations on delivery food side, it be complex. This is look like a monolithic application. All services clubbed into the restaurant. So restaurant guy will tell them, hey, why are you giving these many responsibilities? Why can't you handle your own responsibility by yourself? Suppose something breaks, I am not responsible for that. You have to test thoroughly my object. So what we can do? So better we have a separate responsibilities as divided. That is called single responsibility. Every class should have only a single responsibility. It should be having only one reason to change. Now let's go with the single responsibility. I am creating a class for order food. For this, I'll create a new service and it has its own logic like that. All we have to add all the operations as a new classes. Now I am going to call feedback service. This is the last service which I want to create. This is the last operation. Now we can see here clearly we have divided all responsibilities into separate classes. So now each class it has own responsibility even though if you change something here it will not affect remaining services. So it will be clean and looks good. So now we are done with the single responsibility principle. Let's move on to the next one. Open close principle. That means to say it is open for extension, closed for modification. So software entities should be open for extension and closed for modification. So let's see this one by the example. Suppose now all the responsibilities we have created a different classes. Now we can go with any of the service for this example of open close principle. Let's take a billing service. So let's say I have a billing payment in the billing service. Okay, now bill payment, instead of bill payment, we can say pay the bill. And as of now, my restaurant will accept only pay through UPI. Only UPI payments will be allowed, not other than that. So what I can do that payment method. Now, if payment method equals to UPI, now I can clearly tell that if the payment method is UPI, then paying through UPI. I am not supporting any of the features. So now I close this and I deployed it. It is working fine for payment of UPI. Later, after few days, the client comes with a new feature like he wants to add credit card payment. Okay, cool. He wants to add credit card payment. Okay, I'll completely write here payment equal to credit card. Pay through credit card. Now, what is the problem? As per the principle, I should not modify this because it is completely deployed. It is working fine. Why you are changing existing class? If you change the existing class, again we have to test everything and we are violating the principle. So what I can do? Okay, I can go with the open for extension, not for modification. So I'll be having credit card. Okay, let's go with the open close. This billing service, create as an interface. Now it has a one method. Remove this payment method because we will be having different features, different classes for different things. Now, what is the existing one? We have UPI. Let's create a UPI payment service and extend this one from billing service and override that class. Sorry, override that method. Sorry, my bad. Implements. Now, the client comes with the new feature of credit card. Okay. Now, like that, we have few more net banking. Yeah, this looks fine because in future you want to add another feature like, hey, I want to add debit card service. Can you able to do that? Else, I want to add voucher service. Can you able to do that? Yes, of course I can do without disturbing existing method or existing functionality. So that is cool. That's it. We don't need to do any modification of the existing. Let's move to the next one. Liskov substitution principle. So this is where people will confuse more. So go through properly, listen carefully. Let's take a real-time example. So parent only knows how to use a mobile, but the child who knows how to operate a mobile, how to operate a laptop, how to operate a tab, so all these things he knows. So the child can be replaceable to the parent. So that's what this principle is telling about. As a child, I can able to replace my parent. But still, when you are replacing, it must be having the same feature. But this should be happen without breaking application behavior. Okay, my parent knows how to operate a mobile. I know how to operate a mobile, tab, system, everything. I have ordered all these things to the child. Child knows everything. Now, I am replacing to the parent. When client comes, you want only phone and he is seeing that tab, mobile, everything. So that is not required. Necessary it is focused to the client. No, you should not break application behavior. Child definitely having the same thing should be replaceable to parent. Let's see this one by example. Okay, now we are done with the single responsibility, open close. Now we have to go with Lixo. Okay, let's copy all this class because this is the example we are going to use. I have a billing service, right? I have all these payment options. Now the client comes with new feature that is cash on delivery. So let's create that one as a new feature without disturbing the old one as an open close principle. And it is implementing billing service and it should be extracting implementing the method. Okay. So now here the confusion is cash on delivery service can able to pay at upfront. So this cash on delivery service cannot able to pay upfront. So what we can do? I need to write a separate service. Sorry, I need to write a separate operation. Yeah, that looks good. Okay. COD service is doing cash on delivery, and here I can say payment. It's a payment. Payment is not supported in COD, cash on delivery. Now everything looks good. If you want to replace parent with the child, I can do replace. But what about the pay method? Suppose for example, if you see here, so I will be taking that object. Okay, let's take a client service that pay 100, but my I'll be having COD service. COD service will only support pay later, but billing service does not have pay later. So cash on delivery required a pay later. In this case, we can clearly see that the cash on delivery service cannot be replaced to the billing service. This is violating Liskov substitution principle. Why? Because the pay later service, which is not have in billing service. So how can I replace my child class to the parent class? I cannot do that. What else I can do? Okay, let's go to the billing service. I have one more method, void pay. Okay, this is fine. I my parent class has pay later as well. Now all the classes which is having pay only required need to be implemented this method of pay later. Now now the billing service has a pay later. So now it is supporting. So when I go to the client, I can happily call this pay later. Cool. This feature is working fine. Now the problem is with the client, I don't have it. This time I want to go with UPI, not UPI, credit card. Will credit card supports pay later? No. This credit card does not support pay later. It should support only pay method. So why unnecessarily we are having pay method as well here? Of course, this credit card service can be replaceable to billing service. My child is able to replaceable to parent. The problem is I don't need pay later. Credit card don't need to call pay later. Whenever client calls this pay later, client thinks that I can do pay later to credit card, but this feature is not supported in the credit card. Interface segregation principle. So here clearly telling that client should not be forced to depending on method and they should not use. So what does this mean? We can clearly say that this unnecessarily implementing pay later method. This is not required for the credit card service. The same way, it is not required for the debit card as well. It's only required for the cash on delivery or UPI. We should segregate the interfaces like that. This interface has only these features. Unnecessary features is no need to add. So for that, what we can do? I'll create a new interface, pay now, and it has a method, pay, cool, and one more, pay later. Sorry, I created a class. Okay. As pay later. First, we will do all these things copying to interface segregation principle. This is what we required. So because we are now going with interface segregation principle. Now that's cool. We have two interfaces called pay later and pay now. It is clearly differentiated. Interface has only pay later method. Now, when I come to billing service, when I come to cash COD service, I don't need to go with the billing service. Billing service has both. I'll go with pay later. I no need to override unnecessarily this method now. So this is how I have segregated interfaces like this. We no need to unnecessarily override or implement those methods which is not required to me. So this is how beautifully we have designed from single responsibility to interface segregation principles. Now we have segregated everything in the properly and everything is running fine. Now the next one is dependency inversion principle. High level modules should depend on abstractions, not on concrete implementations. If you see clearly, I'll be using pay now interface here. This is the abstraction level which I am adding high level modules. So with this pay now, I have created credit card service here. I can go with other way like credit card service like this. I can simply do like this. So what will happen? Next time I want to add debit card service. I need to change this one to debit card service. Again, I need to change the constructor. Again, I have to change method or parameter here, the constructor which I am using here. So this approach, so everything will be changed. So we should not change like that. The better approach is just use high level module. If I want to go to debit card, I can directly give it here, debit card service. Simply I can use like this. So this is what dependency inversion principle. So this is all about solid principles. What we will achieve through solid principles, that is easy to extend, easy to maintain, less bugs and better design decisions. So this is the very important topic. So who want to learn any programming language, solid principles is the key for that any programming language. And thanks for watching.